Hello friends, you can log on to primeaptacademy.com to access complete free video courses. So this is the 72nd question of the geometry chapter. So question says a 10 centimeter thick cuboidal tank is open from the top. The external length, external breadth and external height of the tank is 60 centimeter, 40 centimeter and 50 centimeter respectively. Find the volume of the liquid the tank can hold. So volume of the liquid the tank can hold will depend on the internal length, breadth and height. So now this tank is open from the top. That means the thickness that you see will not be present at the top. Okay. So like if you look at it from the top, the tank is like this. It is open from the top. Okay. It will be thick at all other places. Okay. If I may draw the cuboid, if you draw the cuboid, so this is the cuboid that you have. So it is thick from everywhere else, but at the top it is not thick. Means it is, when I say it's not thick, in the sense the topmost layer, you see that the thickness is only with this case. All right. So now at the bottom, if you look at it, now if you take each and every part of it, I want to calculate the internal parameters. So my external length is 60 centimeter and thickness is 10 centimeter. So external length, if in the cuboid, again if I draw it, let this be the external part of the tank. So now this external length, this is 60 centimeter. Now over here, if you look at it, at this part, this is the external length. The internal length will have, there is some thickness here. Also, there will be some thickness here. So internal length will be this external length minus the thickness on both the sides. Okay. So by that logic, now the internal length, what will that be? The internal length, that will be external length minus the thickness on both the sides, which is of 10 and 10. So this is 60 minus 20, which is 40 centimeter. So internal length is 40 centimeter. By the same logic, internal breadth, so now external breadth is how much? 40 centimeter. So my internal breadth will be 40 minus 20, which is equal to 20 centimeter. Okay. Now, but the situation is a bit different for the height. So now external height is given to be 50 centimeter. 50 centimeter. Now if you look at it, with my internal height, what will happen? So again I am drawing this cuboid. So this is the top part of the cuboid. Now if you look at it, at the bottom of the cuboid is like this. So bottom of the cuboid, there will be some thickness from the bottom. Okay. But at the top there is no thickness because it is open from the top. So at the top there is nothing thick over here from the height. So if you do the height calculation, you will deduct the height thickness from the bottom, but there is no deduction from the top that is happening. Okay, because the tank is open from the top. All right. So my internal height will be then, internal height will be 50 minus 10, which is equal to 40 centimeter. This is very important. If you imagine like there is a tank there, at the bottom it is thick, but from the top it is open. So if it is open from the top, there is no thickness for the height as such from the top. Okay. So if my external height is 50, you will just deduct the bottom part of it, the thickness, which is 10 centimeter. So from the top, there is no deduction that is happening. So my internal height is 40 centimeter. Now the volume it can hold, volume of water it can hold will be then internal length into internal breadth into internal height, that is 40 into 20 into 40, which is the internal height, this much centimeter cube. So that is 4 4s are 16, 16 2s are 32. So 32000 centimeter cube. So 32,000 centimeter cube is the amount of volume of water that the tank can hold. Okay, that is how we solve this question.